It says you have this series n equals 1 to infinity n cubed over n cubed plus 1. So when they give you a series and they want you to determine whether it converge or diverge, you apply, we call it the nth term test, where you just need to determine what your limit is. And if your limit approaches 0, then this series would be a perfect candidate. So that means it may converge. Now this one, actually, as n approaches infinity, is not equal to 0. It equals to 1. So then that's it. Stop there. So that means this series would diverge. B. 1 over n cubed plus 1. When you apply the limit test, the nth term test, you get 0 as n approaches infinity, so that means it is a candidate. So now let's apply this direct comparison test. So this is how it works. So you look at this equation right here and you say, what does it remind me of? Which one I actually are familiar with? We call it p-series, if you remember from one of my previous videos. P-series says if you have something like this, and where p is greater than 1, then you conclude that this series converge. Now, if it's less than 1, then it is between 0 and 1, then it doesn't converge. So this one has a little exponent of 3, so that means and it does look like the p-series. So basically what we're doing here, we're comparing this given series to p-series, 1 over n cubed. And we know that this guy converge, right? Now we need to compare these two and decide which one is smaller, which one is greater. Well, just because this part is the same, right? But on the bottom of your original one, you add 1, and that's in the denominator, and that means your denominator gets bigger faster than this one, so that means the whole fraction is smaller. So that means 1 over n cubed plus 1 is smaller than 1 over n cubed. Now, this is a perfect analogy I used to use when I was in high school. So when I compare these two series, and I know that 1 over n cubed converges, and I know that 1 over n cubed is greater than 1 over n cubed plus 1. So let's say this one is 1 over n cubed, and this one is under, it's smaller. 1 over n cubed plus 1, it's smaller. Now, I know that the red one converges, so it's not going up, it doesn't go towards infinity, but it actually approaches a certain number, certain value. So as it approaches a certain value, but the green one is under the red one, so that means it sort of pushes the green one down as well. So it's really hard to show you here. When I see you in person, I'm gonna actually explain better. So this 1 over n cubed it converges, and it pushes the green one, because the green one is under, and that means the green one also converges along. So that means the answer would be this given series converges. Let's see how the next one works. Part C. 1 over 3 to the n plus 2. Well, we're going to compare it to 1 over 3 to the n. Or we can rewrite it as 1 over 3. The whole thing is to the power of n. Now, I don't know if you recognize it, but this is a perfect example of a geometric series. Now, we know that in geometric series, when your ratio is between -1 and 1, in our case it's 1/3, then your series converges. So, this series converges. Now let's see what we have here. Now let's compare. Since you add 2, then your whole fraction becomes smaller than 1 over 3 to the power of n. So this one is smaller than that. Now let's use that same strategy. So 1 over 3 to the power of n. That's greater, so it's above. 1 over 3 to the n plus 2 is smaller, so it's below. Now, the red one converges, so it's not going that direction, because that would be infinity. It converges, we're moving towards a certain value, some kind of value of c. But since the green one is below, then the green one, it pushes the green one along, so it also converges. So that means the series 1 over 3 to the n plus 2 converge as well. D, 1 over square root of n minus 1. So we're going to compare it to 1 over square root of n, or 1 over n to the power of 1/2. So that's another example of a p-series. Now, in p-series, when your exponent is less than 1, then you say it diverges. It diverges. Now let's compare these two. 1 over square root of n, but here on the bottom, you're not adding 1, you're subtracting 1. So that means the whole fraction is going to be greater than 1 over square root of n. Now, what happens? So let's say this is 1 over square root of n, the one we compare it to, and it's smaller, so it's under the green one, which is 1 over square root of n minus 1. So that's, the red one is below. Now we know that the red one diverges, so it's, now the red one diverges, so it's moving towards infinity, and it pushes the green one as well. So that means the green one is also, it also diverges. So our conclusion is 1 over square root of n minus 1 also diverges. E, cosine of n over 2 to the n. Now, I hope this got your attention right here, the cosine.